In this recording, we're going to learn how to solve linear systems by graphing. Well, what's a linear system? Well, as it says here, it's just two or more linear equations that have the same variables. And those could be like a's and b's or m's and n's, but we're going to keep it simple here to start and just use x's and y's because we're familiar with graphing those on the graph. So in terms of relating graphs to equations, as it says here, we've got a couple points here. A point that's an x and a y lies on the graph of an equation if it makes that equation true. If I sub in the x and the y and it makes both sides equal, right? And the graph of the equation is all those points that make the equation true, right? So we're going to determine if this point, 2, 5, is a solution to each of the equations. Okay, so first I'm going to test the top equation out by substituting 5 for y and 2 for x. So I'm making a substitution here, and then I just need to do the math on both sides. So 5 is just 5. And I just simplify this side. I got to do my multiplying before my subtraction, right? And it seems like it checked, right? 5 equals 5, so I say check. But in order for it to be a solution to the system, in other words, both equations, I have to test out the second equation. Use this one in a different color. So I have to be careful here what number I'm substituting for what variable. So let's just write x, y above here so we state clearly that the x is 2. So when I see x, I substitute 2. Or I see y, substitute 5. It is never wrong to use parentheses around the number that you're substituting. If you have a negative that you're substituting, you always want to use parentheses. But in this case, I can just write a 5. Now just do the math on both sides. Play the recording when you're ready. Okay, so hopefully you came up with 4 plus 5 is 9. 9 equals 9. So in this case, it says, determine if the point is a solution to the system. Yes, because it's a solution to both equations, it is a solution to the system of equations. Okay? I'd like you to do part B on your own. Play the recording when you want to check your answer. So hopefully you took time to make these substitutions. So because the point is only a solution to one of the lines, it is not a solution to this system. So, no. Now, what we're going to do is start with a system and try to find out what is that point. If there is a point that they have in common, that's going to be the solution. Okay, so let's have you graph both of these equations and then play the recording when you're ready. Okay, so for my first line, now that I'm familiar with graphing lines as reviewed in the last video, I can jump right to the y-intercept, count up 5. Now I know my slope is 2, so positive 2. Well, I'm out of space there, but I can go in this direction and keep it a positive sloping line. It's going to be pretty important that we label these lines. So after I graph a line, I want to label it. Anytime you have more than one function on the same axes, you have to label so we know which one's which. Now this one's kind of in a funny form. I don't see my y equals mx plus b form. I'm just going to change the order here of the terms. Now I have to be careful here though. I have to keep the negative with the x. So the x is negative, not the 2. Order matters when we subtract. But I can change this to be a negative 1x plus 2, because the 2 is positive, right? So I see my slope is 2, assuming my y-intercept is 2, and my slope is a negative 1. Again, say what the name of the line is. You could use either form. I'm going to use the original form. I think that's probably the more correct way to do it. So we've taken care of graph both equations on the grid. At what point do they intersect? So can you write down the coordinates of that point that you see is the intersection point, please? So if you identified, it's -1 up 3. And now we just need to show that it's a solution to the system, meaning check by algebra. So just like we did in our starting exercise, you're basically substituting in your x and y to show that the point is a solution to both. Do this math here. And it should check. I mean, if we didn't make any mistakes in our graphing. This is just a verification. So why don't you do the other substitution and play the recording when you're ready. Hopefully you made that substitution. Okay, again, when I substitute with a negative, I always want to put parentheses around it. Well, that's really just like 2 plus 1, right? So 3 equals 3. We're in good shape. Nice. Now, when I look at the next example, it is a little more complex. When I look at the one I want to do is number 2 together. So let's go down to number 2 on the next page. They're not set up in slope-intercept form, but you have a little experience of manipulating equations to get them into slope-intercept form. So why don't you do that? Get them as far as you can into y equals form. Play the recording when you're ready. So hopefully you took time to do this. If not, please do. Okay, so that's getting it into slope-intercept form. Now I can graph it, right? So I'm asking myself, what do I need to do to get the y by itself? Well, first there's this 2x that I have to undo by subtraction. These I can't combine, right? They're unlike terms. Which to write? Which order? I want to put the x term first. It's more customary, so it'll look like y equals mx plus b form. I'm going to divide. Those divide to 1. All right, I've got these two equations in slope-intercept form. Go ahead and take time to graph them and play the recording when you're ready. Okay, so the first one, the blue one, it starts at -2 with a slope of -1. Again, labeling. You can use whichever form. I'm going to use the original form here. And now the other graph. I realize I made a mistake. I didn't have any space to write to plot the 9. I realized I didn't divide very well here. -9 divided by -3. I got to fix that. All right, so let's clean that up. Hopefully you saw that yourself and you're like, Mr. Clinton, that's wrong. I'm going to tell you in class. Well, good. But sometimes we catch our own mistakes. Remember, mistakes are part of learning. It's all good to make mistakes. It's nice when we catch them. So 1, 2, 3. Got my y-intercept. The slope's positive. Okay, so let's identify the point that is the intersection, and then let's substitute by checking. Substitute to check algebraically. Okay, so identify the point, the solution set. So -3, 1. And we're going to circle that because that's our answer, right? That's the solution. And now we're going to do the check. So you just go back to that original equation. And you just make your substitution. To show that this comes out true. Okay, so go ahead and do the red equation, please, and show that the point also checks. Okay, so hopefully it took time to do that one. I'm going to show the original equation here. Nice, and it all checks out. Thanks for watching.